In this video, I'm going to show you a cat. It has taken me 1 year to get to this point, where all the mechanics for my racing game are finally done. Now that kind of patience is just a part of life for the independent developer or hobby developer. In this video, I'm going to show you how I implemented the race positioning system, and if that's all you're here for, you can skip ahead to that chapter, because I will cover what didn't work and why, and what some pitfalls are you might want to avoid. The first position system I tried was a series of waypoints that the cars would collide with, increasing their count of collided with waypoints. Whoever has the highest is in first. Sounds simple enough, but the problem with this is that every car now needs to store and update that variable, and you have to calculate off that variable each position in the race, each frame. The accuracy of this type of system is also dependent on how many waypoints you place in the level, which is a large increase in game objects. The next system I tried was fewer waypoints and using a distance calculator. So when the car passes through a waypoint, the system sets the next waypoint and calculates distance to that waypoint. The problem I faced with this system is that while it's fewer game objects, it's one more frame calculation for each car racing, stored into yet another variable for each car on top of the position calculations each frame. And then I went back to a trick Jimmy Vegas used, which is basically a plane in front of the player car to detect collision from other cars as they pass through, and that increases or decreases. The problem with that is that when a car spins, an opponent's car can pass behind the player, causing no collision to happen, thereby not increasing or decreasing. The position system I went with starts with these position markers. These are basically planes or cubes that exist on the racetrack, and if I show the mesh renderer, you can see their position throughout the course. They're mostly on the turns. The whole point of this system is to orient the plane in front of the player car to be what I'm calling track forward, or there's a scene variable that I have that sets the forward vector of the track. So these planes exist mostly on the curves. There's a couple of them on the straightaways, but on the straightaway, so from this point to this point, there isn't a reason to change that vector, so there isn't a collider. On each of these colliders is a flow graph, and this flow graph detects whether or not the tag is a player, and then if so, it's going to set itself, its transform forward, to the track forward variable. And that's not on the update, that's on a trigger event, so it's only going to fire every one of those collisions that it makes, with the player, not any other car. The other thing that makes this system work is that I've got this racing list of cars racing. This is a scene variable again. And each of the cars, this is an AI car, they're all the same, it adds itself to that list on the start event. So it's going to say add to list, add itself to the cars racing list, and the car has one of these also. It's the same, I just copied and pasted. So that way, no matter how many AI cars I add, it will default my position to the maximum number that's on this list. I'll cover the whole flow graph in just a little bit, but I want to make sure I get that covered. Now, these position markers that I have, and I'm going to leave them visible for just a minute. Hopefully I remember to turn them off before we do the demo. I will. I'm sure I will. These only work if we constrain the player's path on the road. So what I've done is in the Road Architect system, you can actually just select a node and then open up the extrusion wizard, and you can choose railings or guards or whatever you want to do to keep the player on the road. Now this probably wouldn't work for like a flying mechanic. You'd have to come up with a different solution, but for any ground-based racing, this would work. So you can see the plane extends beyond the drivable space on the road, and these barriers don't move with the player. So the player drives into them, the car moves instead. It's just a way to keep the player on the track. This system will also work to serve as sort of a position or a direction indicator, to where the player can go backwards, but we could notify the player that they're going the wrong way if I want to do that. I might do that with road signage. Not positive how I want to do that. But you do want to make sure the player can't easily, they may be able to, I haven't found a way yet, but they can't get off the track. So they stay on the track, and then that's what helps these collisions fire with the plane in front of the player that does the math to calculate whether or not the position increased or decreased. Now, there's also a component I had to add in my race manager. So I've got this AI lap trigger. Now that's all this does, this little tiny graph down here. It's going to, on trigger event, it's going to grab itself and then say, okay, did we collide with a position collider? This position collider tag is the AI collider object I have on the AI cars. And then what that's going to do is increase its lap count by 1. So I'll show you this custom event here in just a second. So if it collides with a position collider, it's going to grab the collider and then trigger that custom event. And if we go to the AI cars, we can see that I've added an object to each of these prefabs called position collider. Now it's not the name of it, it's the tag up here. This is what it's comparing with, is position collider with a space and a capital C. I actually had this spelled wrong for a minute, and it wasn't working until I spelled it right. It's going to trigger this custom event and say increase its lap count. Now it's got an object variable, and that's important in this case. It's just an integer, and it counts up from 0. And so it says get the lap count, add 1 to it, and bada bing, bada boom, we're good to go. Now the other thing we're going to need to do is on the start, we're going to need to reset that to 0, or make sure that it's 0 in case there's other races that happen, or if you do this race again. So why don't we take care of that now? We're going to, on the start event, we are going to take this object variable, hold down the Alt key to set it easily. That, and we're going to set it to, we're just going to get an integer. We want an int in system, int literal, there we go. We want to set that to 0. This is just to make sure that if we replay the lap, it doesn't default to this lap count by accident. Should reset, but just to make sure, we'll just make sure it defaults to 0. And since this is the same flow graph, this is AI position lap counter, it's going to repeat what I just did across all the other ones. And we can double check that by just going to these AI cars and hitting on this position collider. Now, something I don't love about Unity's visual scripting is if you have everything named the same, like your naming convention is very similar, sometimes you have to click off of a flow graph and then click back onto a different one to make sure it's the right thing. So we'll go back to the lap trigger, and then we'll go back to this position collider on this car just to make sure that's reset. And it is, and I knew it was. But there's also a collider on the AI car. So let me go, let's focus on this car. And let's take a look here at where I put this AI car collider. It's not quite at the front of the car, it's more like the front axle. Now the reason it's not at the front of the car on the nose is because I want to give the tie to the player. So this is like this sort of on purpose. The car has to pass through the plane in the front of the player car to consider it being in like first place or position change. And I'll show you what that looks like in just a minute. I might tighten this up in a little bit, but I want to make sure that this collider is really past the player before we change the position. So this is just a box collider that is a trigger added to the AI car prefab. Now the meat of the application that I'm doing here is in the position indicator object on the player's car. So again, what we're doing is every update we are setting the forward vector of this object, and let me focus on the player car so we can see it. And what we'll do, actually, I'll turn on this mesh renderer here so you can see like this window pane. I made it transparent when I was testing because I wanted to see it. That's the width and the height, just in case a car, sometimes they drive over each other and kind of get airborne. So I wanted to make it tall enough to capture that. And now this is going to set its track forward position based on that collision from these not from the roadblocks. I set up some roadblocks to make sure the player follows the track from the position system. This is what passes that forward vector through to the position collider on the player car. So let's go ahead and turn off I told you I wouldn't forget, mesh renderer there. And we'll go back to the cars graph, and we will, the position collider rather, and we will see the big one here. Now, this is actually quite efficient. It was a much bigger series of loops and branches when I first started doing this. And this is what I've whittled it down to achieve a pretty good frame rate and some consistency. So first what we want to do, let me actually make this full screen. So first what we need to do is set up a trigger event, and I chose the on-trigger exit event, so the player has to pass through, or the AI car has to pass through the player's pane to increase or decrease that count. We're going to check and see if the tag equals that position collider, which is the AI car's collider. If that's true, then we'll process the next stopgap here, and we want to make sure the laps are equal, right? So if we are a lap behind the AI, it's not going to do anything at all because we don't need it to. We're too far behind. Or if the AI is a lap behind us, we're not going to increase our position yet again because we're on a higher lap already. So the laps also have to be equal. And then we can move ahead in the flow graph to process the next transaction, which is this dot product that you see down below. For that to happen, we've got to get the collider's transform position, and we've got to get the transform position of not ourself. So the self here is the collider's position in front of the player. And we've got to subtract that, just A minus B, and then feed that into the B portion of a dot product. Now a dot product is basically the multiplication of two vector 3's. Now to do this in front or back, you take your forward transform of self, so it's going to set that forward vector and say, that's the blue arrow, and it's going to say, okay, take that blue arrow of vector 3A and divide by, I believe it's a division, divide by that blue arrow of the math in the B side of this dot product. What that math is going to do is say if it's above 0, then they are in front of you. And if it's below 0, then they are behind you. Now you in this case, again, is that plane. So don't think of the car, think of that plane in front of the car. If they are in front of you, again, so it's greater than 0, if they're in front of you, we've got to add 1 to our position, meaning we've fallen behind. So I know it's kind of tricky, but we've fallen behind, and it increases that position count by 1. So that's what you see here. We've got that scene variable for position. That's the player position. We're going to add 1 to it and feed that into a clamp. So that way the position can never be out of bounds, so to speak, just in case the player can jump the shark and do something funny on the track. At the very least, that's like the last fail-safe into not being either in position 0 or 5th out of 4th. You know what I'm saying? So that way the player can't get too janky. And then we just feed that into a set the position to be whatever it needs to be. And then this is not where we set the UI element. The UI element actually does some self-updating. We'll cover that here in just a second. And then, of course, if our dot product math is false, meaning that the collider is behind the wall, basically, we're going to subtract 1, meaning we've gained a position. So we take position, we minus 1, we feed that into a clamp. We set the minimum value of the clamp to 1, and then we set the maximum value of each clamp, in this case, to the total number of cars racing in that first scene variable for cars racing right here. We want to make sure that no matter how many cars we add, we don't have to repeat ourselves and do this math again. And then again, we just set that position. The position indicator is actually a UI element, so we'll go into that, and we'll just find the race position. And this is real simple. Actually, if I go to, we'll go to the scene, we'll take a look at it. It's just a Text Mesh Pro, and what we're going to do is we're going to set that to the position. So, and this does it every update. I don't mind that. It's not a very big change, so it doesn't have any performance issues. We're just going to set the Text Mesh Pro GUI, text set node here. This is actually really tricky to find. You've got spelling counts on this one. It gets kind of funny. And then we're going to take the position and we're going to feed that into a string format. So that way the position is the first number, there's a slash, and the second number is the total value of cars racing again. So that way I don't have to keep doing this. And this string format is kind of neat. It's sort of like an advanced concatenate where you've got your first argument, which is the 0 here, and then it's just a slash to indicate out of, right? Like 1 out of 4 in this case. And then you've got your first argument. It's a real simple way to do it. And then it's also going to set the Text Mesh Pro GUI of our finish place when the race ends. I have it updating both in real time, although you can't see the end screen until the end of the race. That's kind of the logic there for how we are actually updating. So I'm going to do this a couple of different ways. Why don't I make this full screen so we can all see what's going on. We're going to do a race, and I'll pay attention to this green plane here. It kind of changes on its own. And then we'll take a look at it with the position collider's mesh turned off. And this is basically the game at this point. We've got all the mechanics in place. you so much for watching, and if you like this video, please consider giving it a thumbs up and subscribing to the channel. In the next couple of videos, I'm going to go over how I'm going to polish this game and add some things like racetracks and juice it up a little bit, so you're going to want to subscribe to catch all that action before I consider this game completed.